Hey everyone, welcome back to video number 3 for this week, and in this video I'll be discussing how the body responds to exercising in hot environments and the physiological mechanisms that help maintain a stable internal body temperature. Now, as muscular activity increases, ATP is continuously broken down to produce movement. However, only a portion of this energy is released from ATP is converted into mechanical work. So the majority is released as heat, and because of this, body temperature naturally begins to rise during exercise. Now, as I'm doing these calf raises here, my muscles are producing heat even though the exercise intensity is relatively low. So to prevent overheating, my body activates several thermoregulatory mechanisms, and the hypothalamus acts as the body's thermostat and detects an increase in core temperature and initiates these responses to promote the heat loss. The first response is vasodilation, where blood vessels near the surface of the skin widen and increase blood flow to the skin, allowing heat to be transferred from the body's core to the external environment more easily. Another major mechanism is sweating. As sweat evaporates from the surface of the skin, it removes heat from the body, and evaporation is the most effective way of heat loss during exercise, particularly when environmental temperatures are high. Now I'm transitioning into some high knees here. And now that I've increased the exercise intensity, my muscles are going to be producing more metabolic heat, and my body's cooling systems become even more important. Our notes for this week discuss the heat stress index, which is influenced by 3 major environmental factors. So air temp, humidity, and radiant heat, such as direct sunlight. Now I am exercising in my room, so I have the fan on. It's not humid, thank God. And it's sitting at about, I think, 72 degrees in my room. I also now don't have direct sunlight, so it's not that high on the heat stress index. But if you are exercising outside, especially on a sunny day during the summer, humidity will be important, which is because high humidity reduces evaporation of sweat. And then when heat production exceeds heat loss, the risk of heat-related illnesses increase. Now, with an increase in heat illnesses can occur along a spectrum. So early signs include muscle cramps caused by fluid and electrolyte losses. And as dehydration progresses, an individual may develop heat exhaustion, which is characterized by heavy sweating, weakness, dizziness, rapid heart rate, nausea, and an overall inability to continue exercising safely. Now, the most serious condition is called heat stroke, and a medical emergency is when the body's thermoregulatory mechanisms begin to fail and core body temps rise too rapidly. Sweating may stop, neurological symptoms such as confusion or loss of consciousness can develop, and heat stroke requires immediate medical treatment. Again, we're transitioning into our walking recovery, and as I slow down into recovery, my muscles produce less heat overall, and then allow my body's cooling mechanisms to gradually return my core temperature towards a normal level. And preventing heat energy is a major goal in exercise physiology. So proper hydration before, during, and after exercise help maintain plasma volumes and support sweating. It's also important to note that wearing lightweight clothing and allowing time for heat acclimatization, exercising during cooler parts of the day, and monitoring environmental conditions can all reduce the risk of heat-related illnesses.